Alright guys, so we're going to start doing some actual proofs now, and these are going to be very similar to what we did previously. The only difference now is instead of a 2, the word 2, there's actually an equal sign. So all that means is you can pick which side you work from. So you can work from either the left or the right. So I'm going to, basically, it's your choice, but some sides are going to be easier to work with than others. And usually it's easier to work from the side that's a little bit more complicated. So in this case, I'm going to work from the left side. So I'm going to look at this, and again, we're going to use some similar strategies that we've used before, and we'll do something a little bit different. But if you look at this question, I have a common factor here. Both terms have a secant squared x. So I'm going to take that secant squared x, and I'm going to factor it out. And then, if I look at my identities paper, I can replace that 1 minus sine squared x with cosine squared x. And at this point, it's a little bit simpler. I know secant squared is 1 over cosine squared. And I also know that secant times cosine is 1 as well. But either way, I know that I'm going to end up at 1. So very similar to what we've been doing, just pick one side and work with it. So now what we're going to do is look at another one. And this time I'm going to work from the right side. So again, it doesn't matter which side you work from. But whatever side you pick, you have to stick with it. I can't work a little bit from one, a little bit from another, and then say they're equal. So if I look at this question, this is actually a difference of squares. It's similar to something like this, because you know the square root of both terms. Something like that factored into x plus y times x minus y. So it's the square root, and it's you add them and you subtract them. So we're going to factor this in a very similar way. So I know that this is going to factor into, it's kind of hard to see, this is going to be secant squared minus tangent squared because of the square roots, and secant squared plus tangent squared. And now if I look at my identities paper, I know that secant squared plus tangent squared, if I take those identities and I rearrange them, I know that secant squared minus tangent squared, sorry I said that backwards, is going to end up being just 1. So I can take this and replace that with 1. And again, if you have trouble seeing that, let's write that over here. I know that 1 plus tangent squared is equal to secant squared. So if I rearrange this, if I subtract tangent squared from both sides, then 1 is equal to secant squared minus tangent squared. So that whole left side just changes into 1. And now again, if I look at my final answer only has tangent squareds in it. So I need to get rid of that secant squared. And again, looking at that identity, secant squared can be replaced with 1 plus tangent squared. And now I have some like terms I can combine. Anything times 1 doesn't change, so I'm just left with 1 plus 2 tangent squared. And that's it. Now one thing about this question, okay, I could technically, when I was working this, I could have factored that farther, because again, it is a difference of squares. But again, this comes back to looking at our final answer and making it closer to what our final answer looks like. If I know from my identities, that's going to give me 1, and I also know my final answer has squared terms. So if I factor it past that, it's going to be hard to backtrack and get it back to not being squared anymore. Alright, so we're going to do one more. This is going to use a new strategy that we haven't used yet. Alright, and this is going to use something called the conjugate. So you learned what a conjugate was back in Algebra 2, and you used them in 2 cases. When you were using square roots, like if I had 1 over 1 minus the square root of 3, you would multiply by the conjugate on the top and bottom, and the conjugate was 1 plus the square root of 3. Okay, so the conjugate is simply 1 plus the square root of 3. So it's the same thing, but it's a different sign. And the reason we used it is because when I end up foiling this out, those middle terms end up canceling out. So another case when you use the conjugate was with complex numbers. So like let's say you had 1 over 3 plus I. The conjugate was 3 minus I. And again, I multiply the top and the bottom because it doesn't change my equation at all. So what I'm going to do here is I'm going to multiply by my conjugate. And the conjugate's going to be 1 minus the cosine of x. So I'm going to multiply top and bottom by 1 minus cosine x. And again, I'm going to work from the right side here. So on the top, that's going to give me sine x minus sine times cosine x. Remember, that is in parentheses, so I have to distribute that to both terms. Then at the bottom, I FOIL that out, I'm going to have 1 plus cosine x minus cosine x minus cosine squared x. And what's going to happen here, those are going to cancel out. And I'm left with 1 minus cosine squared, which you guys know 1 minus cosine squared is sine squared. So now I am here. Whoops, and I said that was sine squared. So now, since both of my terms have a sine of x in it, then I can cancel one of them out. Okay, so I can divide it out. Another way this could be written, if you had it written like this, with that sine x factored, it would work the same way. I could still divide it out. Okay, so I'm going to divide one of those sine squareds out. So those would go away, or that would go away. But either way, I would be left with 1 minus the cosine of x over sine x. And then at this point, you're practically at your final answer. We just have to have an understanding of fractions here. And I'm out of space, and you make a little bit more space. But if I have fractions, if I have a fraction like, we've already done it, where if I have 1 over x times y, I know I can split that up into 1 over x times 1 over y. That's okay. Alright, but if that was added at the bottom, I could not split it up, because this is not equal to this. And if you think about that with numbers, it makes sense, because 1/2 plus 1/3 is not equal to 1/5. But if I have the same denominator and I'm adding in the numerator, it's okay to split it up. Okay, so like let's say I have 2 plus 4 over 8. That's the same thing as 2 over 8 plus 4 over 8. Either way, it's going to be 3/4. So it's okay to split them up like that. So what I'm going to do is I'm going to take this fraction so it's a little bit easier to see. And I'm going to split that up into 1 over sine x minus cosine over sine x. 1 over sine x gives me cosecant x. Cosine over sine gives me cotangent x. And that's my final answer.